Another unit in AP pre-calculus is going to have a huge focus on rational functions and all of the different characteristics. So this video in particular is going to focus on hole in the graphs and vertical asymptotes. Okay, just the hole in the graphs and the vertical asymptotes. We'll have other videos that focus on the other characteristics. So just as a reminder, a rational function. So make sure you know the definition. We are talking about fractions, right? Rational just means fractions. So you're going to have the ratio of two polynomial functions, and that's going to be the definition of a rational function. And a big thing we're always going to be pointing out, especially in today's lesson, is the denominator cannot be zero, which means that the domain is going to be all numbers except for where the denominator is zero. And we're always going to use the original function before you do any factoring or anything to find the domain. Okay, so that said, let's focus on the concepts we want to look at in this video, which we said they're going to be the hole in the graphs and the vertical asymptotes. So from this point on, if you're asked to find either a hole in the graph or a vertical asymptote, you always want to factor completely the numerator and denominator and simplify. Okay, so we're going to always do that first. So factor completely and simplify. Now, if there is a common factor, which means you had to cancel out a common factor in order to simplify, that common factor is going to tell us where to find the hole in the graph. So wherever the common factor is, if you take that common factor and you set it equal to zero, and whatever that x value is that makes that factor equal to zero, that's going to be the x value of where the hole in the graph is going to be. And then you're going to plug it back into the simplified form to find the corresponding y value. So that's going to tell you the point, right? A hole is a point, but it's a location, but we need to know where to actually put the hole, and we're going to indicate it with just an open circle. Okay, now the vertical asymptote, after you have canceled out any common factors, which means your rational function is simplified, if you still have a denominator, wherever that denominator is equal to zero, that means you're going to have a vertical asymptote at that value, x equals whatever that value is. So in this case, x equals c. And so it is an equation. And remember, we write it on our graph when we do sketches. We're going to use dotted lines to indicate vertical asymptotes. And since it's an equation, we have to write it as x equals a value. It's not just a value itself. Okay, so the equation of the vertical asymptote should be written as x equals whatever value it is. Now, for the AP pre-calculus, we also are going to emphasize down here the limit notation. So we have some limit notation. Add a hole in the graph if you wanted to do a simple sketch to show what this is going to look like if we had a hole in the graph. Okay, so we could just make something that looks like that. So that would be an example of a hole in the graph. Well, let's say that the hole is at some value AD. One second. Let's change that again. All right, so this is A and then this is D. Well, you can see that what's going to happen with the limit notation, and you should have talked about this in a previous lesson, is that as you come in on A from the right side, right, which is approaching A from this side, you can see your function value is approaching D. But we also know that if you're coming in on the left side of A, your function should still be approaching D. So for the limit notation for holes, the right and left side of that x value are going to be equal to whatever the y value is for that hole. But the limit notation for a vertical asymptote, it could vary some. So depending on what the function is doing around that vertical asymptote, but let's just put in a vertical asymptote and we're going to say that value here on the x-axis would just be c. Okay, so here's our x and y axis. And so this is x equals c, the vertical asymptote. Now, your function can be doing a few things. So let's just draw one example of something it could be doing. So let's say it's doing something like that or something like this. Okay, this is just an example. So in either case, you see as you're coming in on the right or left of C, okay, so if we're coming in on the right, you can see that that is going to be approaching the asymptote. And when you come in on the left of C, it's also approaching the asymptote. Now, whether or not it approaches it going towards positive infinity, going up, or going down towards negative infinity, that can vary on the right or left-hand side. But in either case, that's why we say as you approach it on the right, it's either going to approach positive or negative infinity. And as you approach that x value of the vertical asymptote on the left, the same, right? It's either going to be positive or negative infinity. So in this case, on the right side, it's actually approaching positive infinity. And on the left side, it's approaching negative infinity right down here. So it just depends on, the way it's drawn. And if you don't have the picture, you can do some further investigation, but we can talk about that later as we get into some more examples. So let's look at these. This is practicing, and I just have three problems here. We're going to identify the vertical asymptote in the hole, but we could also practice even writing the limit notation if you wish. Okay, so let's go to number one. And we said the first thing you want to do for all of these is you're going to factor the numerator and denominator completely. Okay, now that's factored completely. So yes, you do have to remember how to factor your difference of squares, all your different factoring techniques. So nothing here cancels. There are no common factors. So what that means is there are no holes. Okay, so this graph is not going to have any holes. However, we can now look at where the denominator is 0. So x minus 2 equals 0 and x plus 2 equals 0. That gives us 2 and negative 2. So when x is 2 and negative 2, both of those will be vertical asymptotes. Okay, so these are going to be vertical asymptotes. And so that would be your answer for this particular problem, right? No holes. And the vertical asymptotes would be at 2 and negative 2. Now, if you really wanted to investigate what is going on either side of these, you can substitute some values in to the right of 2 and to the left of 2. You can put them in here, and you can see if it's getting larger or smaller, and that will tell you if it's approaching positive or negative infinity. Okay, so if you're not looking at the graph, that's one way to do it. But let's go ahead and look at number 2. So first thing you do is factor completely. So I like to go ahead and just write in my parentheses. So this is going to be a x plus 2x plus 1. And on the bottom, we're going to have an x minus 3x plus 2. Okay, so that's going to be its factored version, and then we need to simplify. So simplifying, we do have a common factor here. The common factor is x plus 2. So that's going to leave us with an x plus 1 over x minus 3. So just to make a note, this version down here is the simplified form of the function. So if I talk about the simplified form, I'm referring to that one. Now the question is, where are the holes, if any? Where are the vertical asymptotes? So the common factor was x plus 2. So we're going to set the common factor equal to 0. So that means there's going to be a hole when x equals negative 2. So we said earlier that if you want to find the corresponding y value for that hole, if we plug negative 2 into the original, you're going to get a 0 down here. So we're going to plug it in here to evaluate it. So we're going to put it into the simplified form. So if we do h of negative 2, you're going to have negative 2 plus 1 over negative 2 minus 3. And so we have negative 1 over negative 5, or just positive 1/5. So there will be a hole at negative 2 1/5. Okay, so that's going to be part of our answer. Now the vertical asymptote. So I'm just going to do VA for vertical asymptote. Once the function is in its simplified form, we're going to take the denominator of the simplified form and set it equal to 0. So that is just the x minus 3 that's left over. And so when we substitute in 3, mess that one up. Sorry, when we solve, you get x equals 3. And so that is going to be your vertical asymptote. So this one has one hole and also has one vertical asymptote at x equals 3. Now we go to the final example. We're going to do it the same way. Factor completely. So our numerator, this is messing up there. All right, so we have a x minus 3, x minus 3, x minus 1. And then in the bottom, we're going to have an x minus 3, x plus 1. Okay, so that should work there. And now we have a common factor again. Okay, x minus 3 is a common factor. So the whole we know happens, not sure why it's doing that, when x minus 3 equals 0. And so that's going to happen when x is 3. And then the vertical asymptote is going to be when x plus 1 equals 0. And that's going to be when x is negative 1. Now, simplify this a little further. Your simplified form is over there. So we need to get the y-coordinate of the whole. So we can say k of 3 is going to be 3 minus 1 over 3 plus 1, which is 2 over 4, or 1/2. So our whole is going to be at 3 1/2, and our vertical asymptote is going to be at x equals negative 1. So this is just an overview of how to find the holes and the vertical asymptotes. And then in other videos, we can go over the other features, including like your horizontal asymptotes, your slant asymptotes, x and y intercepts, and kind of how to put the whole graph together. Okay, so keep practicing, and we'll see you in the next video.